Great. Welcome, guys. So, what we have seen in the last classes, if you guys remember that, we have covered the spanning tree protocol. Basically, we have seen that we have a two types of loop right now. The loop is not good for the network, not even for the real life. So, you have a layer 2 loop and we have a layer 3 loop. In a layer 3 loop, we have a prevention mechanism that's called as a TTL filled in the IPv4 header. So based on that, we can prevent the loop. This is the size of the TTL is a 8-bit. It means that you have a 0 to 255. Whenever the TTL will become the 0, the router will discard the packet, right? So in a layer 2 loop, we don't have a in a layer 2 header, we don't have any TTL mechanism. So that's why we came with the solutions called spanning tree protocol, right? So we have seen that we have a different flavor in the spanning tree protocol. If you guys remember that, one we have a where's that? Come on. Yeah, that's my. So when we have a CST protocol, that's called a common spanning tree protocol. For all the VLAN, you have a single spanning tree instance. It means that you have a single guy that's gonna manage the all VLAN. Then we have a per VLAN spanning tree protocol. The good thing about the per VLAN spanning tree protocol, what you can achieve the load balancing, right? That's a good thing, which is not possible in the CST protocol. But the problem in the PVST is what it's a slow protocol. So that's why we came with the RPVST protocol, right? Rapid per VLAN spanning tree is a Cisco one, and RSTP is a IEEE standard one. And the combination of all this protocol is known as the MST protocol, right? Then after that, we have seen that how you can do the how you can make a selection of root ports is that
पानी कहाँ रखा हुआ है? पानी सीढ़ी पे क्या?
in a layer 2 network, if you see that, what I can do that, I need to build a loop tree topology. This was my physical topology, right? And from this physical topology, we have created this logical topology. So in this logical topology, you can see that whenever the user 1 that's behind the switch 2 and the user 3 behind the switch 3, right? If this guy's gonna send the packet will go by like this way, right? Still, I have this link, but this link is a block according to the spanning tree protocol, right? What is the election criteria? First, we need to make an election of the root bridge, right? And root bridge always will be a center switch. That's a one topic in the book as well. That's called as a root bridge selection, or where you can put the root bridge. So always be a center switch will be at the root bridge, right? The election of the root bridge will depend on the bridge ID. So bridge ID basically a combination of the bridge MAC address plus priority, and the total is 8-byte number. So default priority is 32768. You can, it's a 16-bit of number, right? 2-byte means 16-bit. It means that you can go with the 65535. The reason is 32768 that I told you that we are going to discuss this thing. The reason is 3268 is what? Because of the mid value. Mid value means what? 65535. If you see the mid value for this guy, that comes over here, 32768. Okay. And then after that, what happened? A lower bridge ID will be always preferred. So who has a lower bridge ID will become the root bridge. So in this case, if you see that this guy has a bridge ID, this one, and this one. So of course, the root bridge will be the A plus 32768. And all the remaining bridges, or we can say the switches, will become the non-root bridge. Then after that, we have seen the election of the ports. And all this information will be exchanged by the one of the BPDU, or one is the message. That's known as the BPDU message. So the ports, we have a DP, RP, and alternate port. So basically on the DP port, we can send the data traffic and receive the data traffic. On the RP port, we can send and receive the data traffic. It means that on all these 3 ports, right, we can send and receive the data traffic. So if you are sending the data traffic from this interface, receiving on this interface, but you cannot send and receive the data traffic from the blocking port. Blocking port, it doesn't mean that your interface is down. Blocking port, it doesn't mean that your interface is down. Your interface is still up. Only the thing is that according to the spanning tree protocol, that port will not carry your data traffic. That's the meaning of blocking port. right? Then after that, we have seen that whatever the election of the root port, the best port on the segment will become the DP port. All the root bridge of the ports will become the DP port, and the lower cost to reach the root bridge will become the RP port. And how the election comes in the picture based on the cost. So the cost will be depend on the bandwidth, or we can say the speed of the link. So we have two types of cost. One is called the root path cost, another is called the path cost. Root path cost is what total cost to reach the root bridge. That's called as a root path cost. Path cost means what? It's an interface cost. That's called as a path cost. So normally, it's a very beautiful questions in the interview. So in a BPDO, which cost we are advertising the information? We are advertising the root path cost information. So at the receiving end, we are adding the cost value. At the receiving end, we are adding the cost value, not the sending side. So whenever the root bridge will generate a BPDO, for example, this is the switch one, and when this guy is going to generate the BPDO packet, in this BPDO, the cost will be 0. So when the switch 2 will receive it, what he will do that he will add the cost will be 4 on the receiving end. That's we have done. So let me show you this in a practical way. So and by default, the BPDO will be exchanged at every 2 seconds. So the timer of the BPDO is what? It's a 2 second. So at every 2 seconds, the switches is going to exchange. Hey, Huawei name, there is something. Don't write on my screen, please. Okay. I can't remove it now. Don't try to write anything. Okay. I'm going to remove you. Please don't write. All done. Now, let's do the lab of this one. And also, yeah, the BPDOs, the timer of the BPDO is a 2 second by default. So at every 2 seconds, switches is extending the BPDO packet that contains the all the root bridge information and the path cost information and many more information. We'll see that. And the BPDO, right, that this 2 second is also known as a hello timer. So somewhere it looks like a hello timer. Sorry. Right, so let me do the lab of this one. So let's go with the spanning tree. Simple one. Oh no, this one. Okay, right. So let me turn on those devices. Let me do one thing. Hold on. Let me first stop and wipe all the countries that I have. Okay, that's done now. Perfect. What I can do that, I'll simply change the police cells. The police is different right now. Session default setting and save it. Perfect. And we have devices. Switch 1, switch 2, switch 3. All done. So now let me put this topology in my paint. Then you guys can help me to draw the loop tree topology. Okay. And just for your information, let me write on this part. Now, which one? The election one. So I'll write it in the paint file. Sorry, in the notepad. Lower bridge ID. Lower cost. Then what? Lower segment bridge ID. Hub is not in the picture, so no need to write the hub concept. So by default, the spanning tree is enabled, right? So on all the switch port interface. So if you see that, the first of all on the switch 1, let me show you that. No, and yes, same thing on the switch 2 as well. No and yes, and switch 3 as well. No and yes. So of course, let me write on the MAC address. I'm just going to write the MAC address for this guy. So the MAC address of this guy is 0, 100, right? And the priority of this guy will be 32768, which is by default, right? Now, in PBST protocol, normally what happened? Whatever the default priority you have, that's a 32768. Default priority, what happened? In a default priority, what happened? We are adding the VLAN number, right? In a PBST protocol, right? And RSTP2. So in the PBST and RSTP protocol, or we can say the RPBST protocol, whatever the priority you have, you are just going to add the VLAN number over there. So for example, right now the VLAN number 1 is by default. So the 32768 plus 1, which will become the 32769. Right? So the priority is now 32769. Okay. But if somebody will ask you, hey, what is the default priority? So default priority is a 32768. So this is the MAC address that I have. So I'm not going to write the priority right now. The reason is that priority will be typed for everyone. So I'm just going to write the MAC address for switch 1. So the MAC address for this guy is 0, 100, right? The MAC address for the switch 2 is 0, 200. And the MAC address for the switch 3 is 0, 300. The reason I'm not going to write it because everyone has a default priority, right? So of course, the switch 1 will become the root bridge, right? So if the switch 1 will become the root bridge, all the interface of the root bridge will become the DP port because this is the best port on the segment. So on this particular segment, right, who has a lower cost? Of course, this one, right? So this guy will become the DP port. This guy will become the DP port. And now if I got to talk with the switch 2 perspective, so switch 2 can reach to this person, right? And this person as well as, so lower cost from this side. So this will become the RP, right? And also this will become the RP. How about this guy? So this guy will become the, of course, if I go through this way to the root bridge, the cost is same way. If I go through this way, the cost is same. If the cost will be tie, then what happened? If the cost will be tie, lower cost, the cost will tie, then we'll look for the lower sender bridge ID. Who has a lower sender bridge ID? Switch 2 has a lower sender bridge ID, right? So in that case, because the switch 2 has this bridge ID and switch 3 has this bridge ID, so this guy will become the DP port and this guy will become the blocking port, right? Now let's have a look. Switch 1. So by default, spanning tree enabled. So let's see which protocol is enabled. So spanning tree, again, as I told you that the default protocol could be the PBST or RPBST, depend on the depend on the platform. So a spanning tree summary, if you just put the keyword, so spanning tree summary, it will show you that it's running with the rapid PBST. So what I can do that simply, I'm just going to change this behavior, spanning tree mode PBST. I'm going to run the PBST protocol, not the RPBST. Enable and spanning tree mode PBST and a spanning tree mode PBST. Let's change the host name. So it's 3. Host name will be switch 1 and host name will be switch 2. That's all. Right? On the switch 1, what I can do that, just wait for some time now. The reason I'll tell you why you have to wait for some time, because the spanning tree has some timer. We'll discuss this thing today. Don't worry. And again, just for the reminder, these are my base MAC address, not the interface MAC address. These are my base MAC address. Right? These are my base MAC address. Interface has a different MAC address, right? So if you see the source spanning tree now, summary, what you can see that the protocol that we are enabling with the PBST mode, for which VLAN number 1, right? So if you see source spanning tree, now what you can see that for the VLAN number 1, because the PBST means what? It's a per VLAN spanning tree protocol. So for the VLAN number 1, if you see that spanning tree protocol is enabled, the default priority, what he's saying that this portion, guys, please pay attention, right? Because if you understand this part, then all the spanning tree will be clear. Right? Here we have 2 things, right? I'm just going to separate it now. So one thing he's talking about the root bridge ID. This part is talking about the root bridge ID. right? And this part is talking about the bridge ID. So right now, the switch one is a root bridge. Switch one is a root bridge. That's why you can see that the same information. So the first of all, the root bridge ID, this root ID means what? He's talking about the root bridge. The priority is a 32769. Why? 32768 is a by default, and he will add the VLAN number 1. Now the address he's talking about the address of the base MAC address of this guy. So I just wrote the last part of the MAC address over here. This bridge is a root bridge, and the default time for the BPD is what? It's a 2 second. That's known as a hello time as well. Same way, this switch is also saying that, hey, this is the root bridge information. Now the switch one itself is a root bridge, and also he will tell that, hey, my information is what? My priority is a 32769. That's fine. That's a VLAN number 1, which is called as a system ID extension. There is a reason behind it, right? Why we call it a system ID extension, but you don't need to do the deep dive for this guy. But yeah, once it comes in the CCI part, you need to learn this part, why we call it a system ID extension for this question right now. But again, nobody will ask you why do we need to system ID extension? What is the use case of this thing? Nobody will ask you, don't worry about that. And the address, see, the priority is a 32768 by default. But I'm going to add the VLAN number 1. Now it's become the 32769, the MAC address, the hello time. That's all. This is the switch 1 information. So according to my database, you can see that, right? Switch 1 is the root bridge. Now, if you go to the switch 2 right now, in a switch 2, if you see the information, right? Do so spanning tree, what you can find that this portion is again what? Guys, please attention. This portion force, right? This portion is going to represent that it's a root bridge ID information, right? So switch 2 also get to know that who is the root bridge, and switch 2 also say that, hey, this is my information. This part. So if you see, according to the switch 2 is saying that, hey, the root bridge is who? The root bridge is the 101, which is this guy. According to, I'm sitting on the switch 2 right now, and the priority for this guy is a 32769. And if the non-root bridge try to reach to the root bridge, the cost to the root bridge is what? It's 100. From which interface? From this interface. And now he is talking about the own information. Hey, also my bridge ID is what? Priority is a 32769, which is by default 32768 plus VLAN number 1. My MAC address is what? 0200. So bridge ID means what? The own switch information. Root ID means what? He's talking about the who is the root bridge. Same thing if you see on the switch 3 right now. The switch 3, same behavior. Do so spanning tree protocol. You can come on. You can see that this is for the root ID. Again, this portion is a root ID. So you can see that the root ID is priority is a 32769. According to the switch 3 now, I'm sitting on the switch 3. And he's saying that, hey, according to me, he is the root bridge. The cost from the root bridge is 100. On which interface? 0/1. And now the bridge ID is what? 32769. The address is 300. And this is the hello time. And now the most important stuff that you have to look for, what? The ports role. So all the switch 1, right? That's my root bridge. All the root bridge interface will be what? It's a DP port. Can you see that? These are the roles, right? Or a state is forwarding. Forwarding is what? I can send the data traffic. And the cost of each interface is what? It's 100. The priority of this neighbor, you will get to know that very soon. Don't worry about that. The type could be the shared or point to point. So this output is not a correct output. It has to be the point to point over here. So because of the simulation, this is the error over there, but this has to be point to point. On a duplex, on a full duplex, you also always see the point to point, right? And on a half duplex, you will also always see that shared. So the type will be, the interface type will be 2 things. Either it will be the point to point, either it will be the shared one. So right now, all are the full duplex right now, but still seeing the shared. So that's a bug, leave it. So now if you see that switch 2 right now, on the switch 2, if you see this interface E0/0, that's my RP port, right? And this interface E0/1 is my DP port. Same way, if you look for the switch 3 right now, the switch 3, we have output. If you see the 0/0, that's my blocking interface, right? And 0/1 will be the RP port. That's my basic lab. Let's do the tricky part. What I can do that, let me open a new lab for you guys, because this is a very simple one. And let's go to the different lab. I'll call this as TP2, not this one. Yeah, I can go with this one as well. Yeah, that's also interesting one. So this will clear the more concept of sanity protocol. So if you see right now, okay, let me put this picture in Paint. Right, and then you help me out. Who will become the root bridge? So let me write down the first of all the MAC address 0 to 100 and the 0 to 100. Again, the priority will be what? 32768 plus VLAN number 1. That's called as the system ID extension. 32768 plus VLAN number 1. This is called as the system ID extension. Right? Same will be on the switch 2 as well as. Right? So the total priority will be 32769. So for example, let me tell you one more thing, interesting concept. For example, if you are doing because we are doing the PVST right now, so per VLAN spanning tree protocol. So if you are doing the spanning tree for the VLAN number 10 or for the VLAN number 10, then priority will be what? 32768 plus VLAN number. What is the VLAN number 10? Then it will become the 32778. Same way over here, 32778. So whatever the VLAN number will be there, they all will be added over here. So now you guys tell me one thing, who will be the root bridge in this picture? Yeah, it's your time now.
Which one?
Switch 1 will become the root bridge, right? Read.
Yeah.
Because of the MAC address, not the priority.
Lowest address.
Lowest MAC address, sir.
Lowest MAC address, right? And this is the interface MAC address, right?
Yes, sir.
Base MAC address.
No, this is the switch
Base MAC address.
method.
Base MAC address.
Correct.
Okay, so non-rigid. Who will become the DP port?
In switch one, both.
Both. And whatever the RP and blocking over here?
E0/0 RP.
E0/0 RP, right?
Yeah.
And this one is
Is-
blocking.
Yeah.
And how do you decide it?
This is based on the lowest port ID. Port
Which
number.
port ID? Sender or receiver?
Sender.
Sender. Great. So if you see that, right? This guy is gonna send the BPDU, right? Switch 1 from this interface, and this guy also. So what happened? Who has a lower sender port ID? This guy has a lower sender port ID, right? So this will be go in the RP port and never in the blocking port. So if the cost, see, in this case, what happened? The cost will be tied. Bridge ID also will be tied, right? Because both have say, if this guy is gonna send the BPDU, let me tell you this thing. This is a little confusing one. So if this guy is gonna send you the BPDU packet, what will be the bridge ID? If the cost is tie, what will be bridge ID now? So 0/100. And what is the bridge ID for this BPDU? 0/100. So if the bridge ID, right, is tie, then it will go with the lower sender port ID. So who has the lower sender port ID? So of course 0/0. So this guy will become the RP and this guy go in the blocking one. So now if you see that this person, switch 1, switch 2, and
Sorry, sir. I just like to have a little bit more clarification about this. The switch one, both are designated ports, right?
yeah, okay, that's root bridge because of the root bridge, right?
Okay. So this is the indication when it's a root bridge, and the other one is a non-root bridge. So when it's a non-bridge, one is a blocking port, which is understandable. The the down one on the right hand side
Yeah.
is R is R stands for what?
RP, root code.
Well, that is the tricky part. How come it's a root port when it's
Okay,
not
okay. Okay, the first,
root bridge.
first we'll look for the lower cost, right? So the cost will
Okay.
be same, right? 100 and 100. So if the cost
Sure.
will die, then what we will do that? Lower send the bridge ID. So if the switch one is gonna send the BPD from this interface and this interface, what will be the bridge ID in this one? 0, 100 and 0, 100, right? So again, this will be also tied, right?
Okay, the cost is 100 and the bridge ID is also 0, 100.
Yeah,
I mean,
on the both BPD, right?
I mean, is that the by default or just
It's a default one because when the switch one is gonna generate the BPD,
okay, sorry, 0, 100. I see.
yeah. You see that?
I
when
see.
the
So
switch one is
this
gonna
is
generate
actually
the-
sending.
So now it will look for the lower sender port ID. So who has a lower sender port ID? This one or this one?
0/0.
0/0, right? So he will
Yes,
be,
sir.
so I'm receiving the BPT on this particular interface. So he will be the winner for that one.
I see. Right. Okay. So in simple words, 0, 100. I mean, this is the MAC address, but this
This is
is
the MAC
also
address,
the
right? Yeah.
exactly. So, but this is also the bridge ID. Is that right?
Bridge ID is a combination of what?
Bridge ID is a combination of the
Priority plus MAC address, sir.
Priority,
address.
priority tie ho gaya yahan pe. So priority is tie now, right? So
Yes,
what I
sir.
am looking for the base MAC address, right? Who has a lower base
Ah.
MAC
Yes, sir.
address?
Got it. Thank you so much. Very well explained. Thank you so much. Take
Switch
care.
one, switch two now. So if you see the switch one is the root bridge right now. Okay, priority is a 32769. This part is gonna talk about the root bridge. And
No
this
problem.
part is gonna talk about the bridge ID, right? Same thing, both
No,
the bridges
that's
are
fine.
working right now. And if you see the switch two is saying that, hey, right now you're sitting on the switch two. Switch two is saying that, hey, according to my database table, the root bridge is home. The root bridge is 100 now. That's the switch one. And what about my port route? So it 0/ go in the root forwarding, and this will be go in the alternate blocking. Now let's go with a different lab. ये कौन सा lab है? Hold on, guys. We did it. This is good. So switch one we have. Switch two we have. Switch three we have. Okay, I'll put the switch three over here. And switch four we have.
Sir, cost is in your previous lecture, cost is a little bit tricky to remember. Is there any like
It's not mandatory to remember. I told you that. It's not mandatory. Why you gonna remember it?
No, I'm not talking about those numbers. So it was equal to root cost equal to, I don't remember now because I heard about 3 times the lecture, still forgot that. But
Why you
I
gonna
will
remember?
message you.
You are gonna remember the values of the cost. You are trying to remember it.
No, I'm not talking about the values. It's just the standard, which one is to choose, which one is not to choose. The formula, I'm talking about the formula.
Oh, this one you are talking what?
I will share you on the WhatsApp later on.
Sure.
I don't want to disturb you now.
And now if you see, help me out. Who will be the root bridge now? Who will be the root bridge?
Which one?
Switch one.
Yes, sir.
DP,
So switch one.
and RP. Who will be the RP on the switch two? Let's talk about the switch 2 perspective right now. Who will be the RP?
0, 0, 0/0.
Okay, I'll let you know the cost is right now. So the cost is same right now, 100, 100, and 100. So according to the switch 2, that this will be the RP, right? How about the switch 3 now?
Yes. Same 0/0.
Same 0/0.
Yes.
आप बताओ switch 4 के according कौन होगा?
Zero slash one, sir. And 0/0, sir.
No,
दोनों होगा.
zeros.
Both will be there. 0/0 and 0/1.
No,
0/0.
0/1, sir.
Zero
0/1, sir.
slash
Zero.
is
Zero
one
slash zero.
on switch 2
0/0.
because of the lower MAC ID and all that combination.
Oh, 1 minute. So on the switch 2, it's correct. Because of the lower cost, right? I will go with the lower cost to the switch 1. From this side, the higher cost is there. So this will be the root port. This is correct. On a switch 3, also this is correct because from this side, the cost is very lower to reach the root bridge and the cost is very high to reach the root bridge. So this will be the root port. So that's a correct one. Root port is correct on the switch 2 and switch 3. How about the switch port?
Switch for 0/0 because of the
0/0 Ethernet.
Okay, let's see. So if I go through this way, what is the cost is happening?
200.
What
200.
the cost is happening?
200.
So if the cost will be high, then what is the next picture we have?
Bridge ID.
Sender
What sender
bridge
bridge ID,
ID.
right? So let's take example.
sir.
If the cost is tie, so switch 2 will also send the BPDU to this guy, and switch 3 also send the BPDU to this guy, right? Right now.
Yes, sir.
So you are sitting on the switch 4 right now. So according to you, who has a lower sender bridge ID?
Switch to
Switch 2. So this guy will become what?
root port.
Now. So if this guy is a root port, right? So let's make Alexa now. So in front of the root port, because he's sending the BPDU from this interface, I'm sending the BPDU. So this guy will be the DP. And from this interface, I'm sending the BPDU, this guy will be the DP, right? So of course, this will be in the blocking state, right?
Yeah.
Okay, let's do this one, switch 1, switch 2, switch 3, switch 4. So spanning tree summary, very beautiful command that will tell you which protocol you have enabled, right? So spanning tree, you can see that the default priority is a 32769, and all these ports are a DP port right now. If you go to the switch 2, according to the switch 2, the root bridge is 100, and my port roles are DP, this interface, and this interface is the RP, correct? How about the switch 3 now? If you look for the switch 3, so spanning tree. So according to the switch 3 now, this guy is a root ID, root bridge, we can call it. The cost to reach the root bridge is 100, from which interface? 0/0. Port, root, and DP. Understood? Right? And now,
Sorry,
yeah.
what I was saying that if you take a look at the switch 3, which has a switch ID 0300, right? So that is a neighbor of the switch 1, and the switch 1 is the root bridge, right? So link which is going to the switch 1, okay, it will be always considered as a root port, right? It is
Because of
always
the
like
lower
that.
cost, because of the lower cost, right?
The lower cost is at the switch 1, isn't it?
What do you mean by this one?
So which one has a lower cost here?
Okay, you missed that point. It was lots of bad. 1 minute, hold on, I'll explain. on, remove it. So now, so right now, so the map, I'll write 100 is the cost of this thing. Let me do one thing. 100 of this cost, 100 of this link cost, and 100 of this link cost, right? This is the root bridge. You understood this point?
Yeah, that's fine. Yeah, this is the
Okay.
root bridge, correct?
Okay, this interface is DP because of the best port on the segment, right? Correct?
Uh,
All
as
all the root bridge of the interface will become the DP port because of the best port.
Yeah.
Right?
that's right. Yeah, that's fine. Yeah.
On every, I have mentioned this point to write on everyone. So have you wrote it or not, everyone? This part? It has to be in your handy. What is the definition of root port?
Uh,
Every non-root bridge try to find the best part of the is the root bridge, and how we define the best part based on the lower cost, right?
mhm.
Okay, now let's come back.
Okay.
Now, so according to the SysTo, right now you're on sitting on the SysTo. You tell me one thing. Who will be the? So if I go to the root bridge from this side, and if I go to the root bridge from this side, which one is the lower cost? See, I have a two path, right? This guy, switch to will reach the root bridge from the two path, from this interface and this interface, right?
Yes, sir.
Majid,
Yes, I'm listening to you. Please go ahead. I'm listening to you.
I'm asking to you.
Yes. Yes. So on a switch to, there is a two paths. One is that there is a direct link to the switch, and the
Forget
other
the
one.
direct, always tell the interface. This interface and this interface, 0/0, 0/1, which interface?
So yes, so E0/0, that is a lower bridge ID. Yes.
Not lower way, lower cost.
But the cost is 100, isn't it?
The cost is, if I go to the root bridge from this side, what is the cost is happening? 100, right?
Yes, that's right. Yes.
And if I go through this way, what is the cost is happening? 100, 100,
Ah,
100.
300. Correct. That's right. Yes.
Now you understood the RP. Why he's the 0/0 is RP?
But the cost is adding up.
Because of the lower cost, right?
Yes, the lower cost is here, but okay, that's okay. But okay, so if we okay, so I mean between switch 2 to switch 4,
Forget the
the
switch
cost.
to right. Forget the switch to switch 4 right now. Don't do that. What I told you that. Always find the root port right now on every switch. So every non-root bridge have a single root port, right?
Mhm. So basically, what the conclusion is, we need to calculate the cost. Wherever the low cost is, just follow that. Like
Exactly. If the
so.
cost will be tie, then this guy will comes in the picture. If the cost
Okay.
tie, then this guy comes in the picture, right?
Sure.
Let me, guys, please make a handy of this thing, because if you're not gonna make a handy of this part, you will never understand the spanning tree protocol. Make a handy of this part. Take a screenshot, take a snap right now in your phone, and always keep, every non-root bridge, you will only have a one RP. So we have done with the switch number 2. Now we have to go with the switch number 3. So first we need to find the RP. Understood? Let me take my screenshot because I know you guys will not take. Now, Nadir, help me. Any question on the switch 2 right now? Is done?
Yeah, that's fine. That's done. In terms of cost, that's fine. Thank you.
Next is what? On which switch now? Switch 3, right?
Next is the
Switch 3.
switch 3. That's right. Yes.
Because we need to find what? Every non-root bridge have a 1 RP. So we have done with the switch 2. Now
Mhm.
the non-root bridge is a switch 3, right? So if you go to the non-root bridge that is switch 3 right now,
Mhm.
tell me one thing. If I go by this interface 0/1 to the root bridge, what is the
Okay.
cost? If I go by the 0/0, what is the cost?
100.
Who will become the root port now? 0/1 or 0/0?
0/0.
Great. Now, still same one. Every non-root bridge, you will have only 1 RP. So we have done with the non-root bridge. We have done with the non-root bridge. Now the next part is what? Switch port, right?
Okay.
Switch port is also a non-root bridge, right?
Okay. So we have to calculate the cost again.
Again, so let's see. So if I go by the 0/0 to the root bridge, what is the cost?
It's 200. It's the same both side.
Or the same,
Two
right?
hundred, sir.
So if the cost will be
Yeah.
tied, then what happened? What we have to look?
Uh,
Lowest center side bridge ID
Center
बोलिए
bridge
sir.
ID.
Priority. Center bridge MAC ID.
Lower center bridge
Yeah.
ID. So tell me
Yes,
one
sir.
thing. If the root bridge is gonna generate the BPDU packet,
Mhm.
right? Switch 2 will receive it, and switch 2 is gonna send the BPDU packet to whom? Switch 4, right? So when the switch 2 is gonna send the BPDU packet to the switch 4, what will be the sender bridge ID? 0200? This MAC address?
That's right. Yes.
When the
Yes,
switch 1 is
sir.
gonna send the BPDU packet to the switch 3, and when the
That's what.
switch 3 is gonna send the BPDU packet to the switch 4, okay, 1 minute. Switch 4, what is the MAC address will be there? 0300? Right, in this
Yes, sir.
BPDU
That's right.
packet?
Yes, please. Yeah.
Which one is the lower one?
Is the 200 the switch to?
So this interface will become what? RP.
Ru- RP root port.
Understood? So who is
Mhm.
sending the BPDU? Always the DP port will send the BPDU, designated port in the PVST protocol. So he's sending the BPDU, it will become the DP, and it will also become the DP because he's also sending it. So this guy will go in the blocking. Remaining only you have one. So both blocking.
So remaining always will be the blocking port.
If
On
you have
blocking
done with
state.
the RP and DP, the rest of the part is the blocking only.
Okay, alternate blocking port. I see.
So now if
So
you see,
basically,
go ahead.
the root bridge always have the designated ports.
Always.
That is the standard. That's the standard thing.
Have you watched
Right.
the video?
Yeah. Yeah, of course, 3 times.
Have you make a note of this thing?
This thing is what has been keep confusing and forgetting. Yeah, but no, it's all clear. Thank you so
It's a
much.
very important one.
Yeah, it's very very important. Even I took the screenshot, but was a little bit was
Cannot
too
be.
much.
It
But anyway,
happens. See, I told you that it happens. Spanning tree is a little tricky, and that's why many people doesn't understand the spanning tree protocol. So most of
no,
the
no, no.
people,
I appreciate that you explained very well. So it's everything clear now. Thank you.
no,
Thank you so
most
much.
of the people are leaving the networking because of the subnetting or spanning tree protocol and BGP. These three things. Subnetting is the first step. Spanning
Okay.
tree protocol is a second step, and BGP, that's a third step. And if I talk about the higher level, if you go to the CCI level, the fourth step is the QS and multicast. So this is the
Okay.
tricky part. So till the CCNP level, you have this thing. In CCI level, you have this thing. So these are the high level of things that always get confused by the engineers. Okay, now let's do
Okay.
this one. Okay, let's do it. Okay, so same one. I will take the snip of this guy first of all again, because I really need to take it. I don't need it. I think so. I can done from here to it. Yeah, I can done it from here to it. So again, the MAC address I'll just write on. So the MAC address is 0, 100. The priority will be tied, right? 32769. 32768 is a default plus VLAN number 1. Switch 2 is a 0200, 0300, and 0400. Now, this will be the root bridge. So if this is the root bridge, he will generate the BPDU packet. So all the interface of the root bridge will become the DP port, DP port, DP port, DP port. Now, let's talk about the switch 2 perspective first of all. Cost, I'll just write out. So the cost will be 100, 100, 100, and 100. So let's talk about the switch 2 perspective. You are sitting on the switch 2. If you go from this side, 0/0 to the root bridge, and if you go by the 0/1 to the root bridge, and I have a 2 alternate path as well, from this way as well, right? And from this way as well. Which one is a lower one? So this guy is 100. This guy is 100, 100, 100, 300. This guy is a 200, and this guy is a 200. Take some time, understand. Is it correct cost or not?
0/0.
0/0 will be lower one. Understood, guys, everyone?
Yes.
Yes, great.
Yes,
So now-
yes, sir.
So this will be the RP, right? Let me take a different color. We have done with the RP because every non-root bridge have only one RP. That's we have done. Now let's go with the switch 3 now. Switch 3 perspective, if you talk about, if you go to the switch 1, cost is 100. If you go to the switch 1 from this side, the cost is 300. 100, 100, and 100, 300. If you go by this way, then what? 100 plus 100, 200. If you go by this way, then what? 100, 100, 200. Which one is lower?
0/0.
0/0.
100.
101. Now the switch port. Switch port. If I go by this way, what is the cost? 0/0.
200.
If I go by this way, then cost is.
200.
If I go by this way, then
100.
100.
100.
so 100 is
100.
die, right? So of course this guy will not become, right? 200 will not become. So let's ignore the 200 right now. Now let's make a lesson of this interface. This 2 1. Tell me
0/3.
why 0/3.
Just lower port ID. Sender's port
Perfect
ID.
answer. Because if you see, I did the manipulation over here. Can you see that? I made the 0/3 from this side. Over here 0/2. And from the 0/2 from this side, I made the 0/3 this side. So there's a difference is happening. So the Firoz said that it's a 0/3 will be the RP, right?
Sir, repeat again.
Okay.
Here, which one is sender here? Switch 4 or switch 1?
What is the sender?
Sender means
BPDU?
Root bridge is a sender. So always.
Root bridge also will always be a sender. So if I go by this way, what is the cost? 100. If I go by this way, then what is the cost? 100. So if the cost will be tie, then what we have to look? Lower sender, bridge ID, right?
Bridge ID.
Bridge ID is also tie.
Okay.
Then what we have to look for this guy? Port ID, right? Who has a lower sender
Yes.
port ID? This guy, right? So if you see
Yes.
this bridge, always the switch 1 is going to send the BPDU. So this one is 0/2, this is 0/3. So if I'm receiving it, who is the sender? This guy. So 0/2 will be the
0/2.
sender. Not we have
Yes.
to look for the receiving end. So 0/2, this interface will become the RP port.
Yes. Thank you, sir.
Now, BPD is coming from, understand, BPD is coming from this interface and he's going to forward to this guy, right? So this guy will become the DP. Understood? Same way,
Yes, sir.
it is coming from this side to this side. So this interface will be on the DP.
DP.
How many blocking you have on the switchboard? Can you see that how many blocking you have?
3.
1, 2, 3. Eventually, you will have only one path to reach the root bridge. Eventually, in your default behavior, right? For the single VLAN. For the single VLAN, eventually you will only have a one root bridge, sorry, one path to reach the root bridge. So if you see now the output, switch one first of all. Switch to now. According to the switch to, right? 100 is the root bridge. And if you see the 0/0 is my RP and 0/01 is my DP. How about the switch 3 now? According to the switch 3, root bridge is 100 and these are my port rules. 0/0 is the RP and 0/1 is a DP. Switch 4, that's an interesting one. Except the 0/3, all my blocking. Understood?
Yes, sir.
Great. Now, how can I change the root bridge now? If I go to the switch 2, I want to make the switch 2 as a root bridge. I can't do the base MAC address changes, right? What I can do that is simply, I say the span tree VLAN number 1. I say the priority is 1. If I'm going to make the priority, lower priority is always winner, then the MAC address comes in the picture, right? So always the first selection is what? If you see, I have mentioned this point over here. The first is always the lower priority. If the priority get tied, then it comes to the lower MAC address. So I cannot change the MAC address. I just go change the lower priority. I want to make the switch 2 as a what? A root bridge. See, I'm defining the priority is what? 1. What is telling me? You cannot define the priority into the 1. You have to always in the 4096. 4096. How many bits? How many bits? 4096. 12 bit, right? Remember, have you seen the 12 bit anywhere in the network till now? Whatever you have learned till now, have you seen anywhere the 12 bit?
No, sir.
Anyone? Firoz, Anil, Sakil, Bujar?
No.
Then what is the need of VLAN, the man? Why you have read the VLAN then? Revise your VLAN. The size of VLAN is a 12 bit.
Okay,
Problem.
sir.
That's why we came with the private VLAN, remember? So the reason we
yes,
have
yeah.
a 12 bit is what? Because of the VLAN. The 12 bit is what? 4096, right? That's why we have an increment of what? 4096. This is the reason behind it. And now, so always either you can make a priority 0 or either you can go with the 4096. And the mid value is what? 32768, which is the default priority. So if you want to change the priority of the any switches, you have to choose the any of one of them. If you are choosing any other values, they will throw the error message. So what I can do that, I'll simply say that priority is 0 right now. So if I make a 0, what happened? It will become 1, right? Because 0 plus 1, that's my VLAN number. So now if you see the do so spanning tree, my root bridge is switch to not the switch 1. So finally he will become the root bridge and all the LXL will be changed now. So the switch to all interface is now become the DP port. Understood? Right, so this is all about the labs. I want to show you something else. In a Cisco packet tracer, with the last one. Yeah, because in an interview they're asking this question many times. I have seen that. Not again, not used in the production network, but interviewer are asking very much this kind of questions. Where's the video is not there today? There's some slack not there. Confirm guest. And I can take a hub. Again, nobody is using right now. We are just doing our lab. The reason is that this kind of scenario is coming in the interview. Not this one. Of course, the spanning tree is a layer 2 protocol. Hub doesn't understand the spanning tree protocol. So in this case, what happened? Which one will become the root port and sorry, DP port? Tell me. I'm gonna generate the BPDU. Switch one hub will receive. What hub will do that? Hub will just broadcast it. Same way from this interface, I'm gonna send the BPDU. He will receive and he will make a broadcasting to this interface. Right? So loop will be there. So to prevent this loop, what we have to do there? We need to make a one port as a shutdown, right? So if you see the 0/2 is a sub shutdown. The reason is that I'll tell you. Now understand this concept. So let's take a red one. So when the 0/1 is going to send the BPDU packet, right? Right. So once he going to send the BPDU packet, what happened? Same one will receive on the 0/2. Right. Now the same way, when the switch 2 is going to send the BPDU packet, this will receive it. So when the switch 2 is going to send the BPDU packet, in this BPDU packet, what happened? They will put the what own port number. And when the red one is going to send the BPDU packet, he will put the own port number. So you tell me, right, which one has a lower receiving port ID? I'm not sending it. I'm saying lower receiving port ID. So 0/1 is a lower receiving port ID, right? That's why 0/1 will go in the DP and this will go in the block. So when you have a hub in the picture, then you have to look lower receiving port ID, not the center one. When you have a switch, you look for the center. When you have a bridge, you have to look for the receiving. The reason is that because hub doesn't understand the spanning tree protocol. It's a layer 1 device. It's a layer 2 device, right? A protocol is a layer 2. The spanning tree protocol is a layer 2 protocol. So when I'm going to transmit this data, BPDU, it comes me over here. So I will look for the receiving port ID, not the sender one. Understood? Now, next part that I want to show you guys. Hold on. Okay, let's do the tricky over here. Some tricks. Not this one. Let me go with this lab. The states that have to look. 1 minute. Let me stop this guy. I'll make a simple lab. Let me check the one lab. So I need to create the topology right now. So in the where you need to map create the mapping net map. Not you don't have like a graphics like that. Switch 1 0/0. So one means switch 1 0/0 interface is connected with the switch 2 0/0 interface. That's all. Name the switch 1, switch 2, and I have a layer 2 image. Let's make a iron image, and just make the iron is this is the switch. Okay, right? So here we have this one. Now, right? Spanning tree states a very important topic. So the normally what happened when you wanna connect your switches, right? Switch 1 and switch 2, right? So normally this interface will not come immediately in the forwarding state. So what do you think? Take example, I just connect the switches between the two, I just connect the two switches, right? And I have a PC and connect them. So what do you think? Will this PC will get the internet connectivity immediately? No, it's not like that. So PBST protocol, right? PBST protocol takes some time to bring this interface into the forwarding state. PBST protocol takes some time to bring this interface into the forwarding state. If the interface is not in the forwarding state, then in that case, you cannot send your data traffic. So all this interface, right, whatever the interface that you can see that even the access port as well, all the trunk port or access port, if the spanning tree is enabled, then it has to follow the states over there. So the first states that you can see that it's known as the disable state. The meaning of disable state means what? It means that the spanning tree is not running over there. It means that your port is shut down right now. Simple language. This state is a special and not a part of the normal spanning tree propagation. It means that this is the normal disable state. Disable means what? Simply I have disabled the protocol right now. That's the first step. So right now, all the interface is the part of the disable state, right? So what I can do that, right? I'll to show you the states, because normally you cannot see that. What I can do that, I'll just take a console first of all. Let me no yes and no yes. And I'm gonna enable some debug right now to just show you the behavior of the states. Right. Enable switch one hostname. Of course, the switch one will become the root bridge, right? Because of the lower MAC address. Switch to Swiss spanning tree summary. Which one is there? RPVST. Let me change this guy. Right. And what I can do that, I'll just enable the debug spanning tree events. Debug spanning tree switch state. Right. To show history. And same debug, I'm gonna do that on the switch to right now. Perfect. Okay, all great. So what I can do that, I'll just gonna make all the interfaces down right now. So do so IP interface, whatever the interface I have. I have a huge interface man, so I'm only gonna look for the 0/0. So I'm gonna shut down all the interface. 0/1 interface going each 0/1 to 3. I think we have 3 shut down. Interface each 1/0 to 3 shut down. So my all interface is done right now, I hope. Yeah, all the interface is down, only the 0/0 is up. So if the interface is down, it means that there's no spanning trees going on. So I don't want to see the huge debug message. I just want to see the debug for the interface 0/0. Interface range is 0/0 to 3. Shut down. Interface range is 0/1 to 3. Shut down. Sorry. Each 1/0 to 3. That's done. Okay, so a spanning tree interface brief. Sorry, so a spanning tree. Let me shut down this interface as well. So this interface are the down right now. This one is totally down. So it means that there is no spanning trees going on. Now, the next step, right, that you have seen that. The next step you have, once you up this interface, right now it's a down interface right now. Once the network engineer go and the interface and say that no shutdown, then what happened? Just for the guys, pay it just for the millisecond. Just for the millisecond, your interface will be jumped into the blocking state. Your interface will be jumped in the block. Just for the millisecond, your interface will be jumped in the blocking state. Millisecond only. To just see that, is there any loop or not? So after the port has initialized means what? The port is up right now. If the port is down, disable. If the port is up, it means that we are moving in the initialization, right? It begins in the blocking state so that no bridging loop can be occurred. In this blocking state, port cannot receive or transmit any kind of data traffic. Not even I cannot learn the MAC address in the MAC address table. Instead, a port is allowed to receive the only BPDU so that the switch can hear from another switches. That's all. So in the blocking state, we are not doing anything. Normally in the blocking state, what we are doing that, I'll just make a summary over here. In a blocking state, no data, right? No MAC learning. Simple language. Only what we are doing that? Only listen BPDU packet on the blocking port. So normally on the blocking port, we are receiving the BPDU packet. So if you have a switch 1 right now, switch 2, switch 3. So this is the blocking port. So on this particular port, I'm keep receiving the BPDU packet. So on the blocking port, I will keep receiving the BPDU packet so that I will get to know that switch 2 is working fine. So after that, what happened? After just spending the few milliseconds in the blocking state, I will jump into the most important state, that's called the listening state. And from here, the timer will be begin. So from disable to blocking, and from blocking to what? It will go to the listening. The name suggests that, right? The name says listening means what?
Port up.
The name says that listening means what? Now I can receive the BPDU packet. After receiving the BPDU packet, what happened? I will make the port election. So in this listening state, what happened? Your port will be spent 15 seconds, right? Again, these things we are talking about the PVST protocol perspective. So we are going to spend the 15 second. Next part is what? We are going to make a port election. So if you see the line over there in the listening one, a port is moved from the blocking to the listening state. So in this listening state, what happened? My root port will be elected and DP will be elected. So whatever the port will not become the RP or DP, whatever the port that will not a part of the root port and DP port, obviously in the blocking port, right? So that blocking port will be go in the blocking state packet. So in this listen state, what happened? RP will be there and DP will be there. So if the blocking port will be there, so what happened? This blocking port will be jumped to the blocking state. It will remove from here and it will go back to the blocking one. In this again, next part, the most important one, I'm not going to send the no data traffic, I'm going to send it, right? So user traffic will be not go and no MAC learning. Then next step we have, it's called the learning state. As the name suggests, the learning means what? Again, I'm going to spend the 15 second over there, first of all, right? 15 second I'm going to spend in this state. In this learning means what? I can learn the MAC address. I can learn the MAC address. Now, what we are not going to do that. Still, we are not going to do that. No data traffic and get sent. I'm not going to send up any data traffic. I can only learn the MAC address. So after a period of the time called as a forward delay, that's called the list forward delay is a 15 second again listening state. The port is allowed to move in the learning state. The port still send and receive BPDU, right? There's no issue in the BPDU because based on the BPDU, we are gonna make an election, right? In the addition, the switch now can learn the new MAC addresses to add the address table. So we are gonna learn the MAC addresses. This gives the port an extra period of the silent participation and not allow the switch to assemble the at least some address information. The port cannot yet send any data frames, however. I cannot send any data frame. I can only do the part of what? Learning. Finally, after the 15 over here and 15 and 30 second, now the interface will move in the forwarding state. So in this forwarding state, what happened? I can do everything. I can send my data, I can receive my data, I can send the BPDU, I can receive the BPDU, I can learn the MAC address, everything I can do that in the forwarding state. So normally your one interface, if the interface is down, it take a 30 second to put this port into the forwarding state. 30 second it will take to put the port into the forwarding state. It means that after the 30 second, the user will send and receive the data. 30 second means 30 second is a huge, like a 30,000 millisecond. In a 1 second, you have a 1,000 millisecond. 30 second, you have a 30,000 millisecond. So for the 30,000 millisecond, your user will not send and receive the data. You will lose a huge amount of voice and video traffic, or we can say the delay sensitive traffic. Can we skip this state? No. In PVST, you cannot do that. And that's why RPVST comes in the picture. That's why this is the reason that the PVST protocol is a slow protocol and RPVST comes in the picture. So if you see this part, let me show you the debug behavior. So my both port is down right now. What I can do that, I'm simply gonna unset that. So right now both interfaces down. So these are then the disabled state. So if you put the command source spanning to summary, source spanning interface is 0/0. Can you see that? This interface is down, right? Shut down. So no spanning tree is there right now. What I can do that, I'll just gonna up this interface, right? No shut. I'm gonna put the same command on, I'm gonna put the enter on the same time. So that you will see the output behavior. Now wait for some time. I will show you the debug message. Hold on. You need to wait for the 30-second, man. We can't do anything. All up. So now I can see that the first thing, focus on the timers. That's a very interesting one. So the interface is up now, right? I just put the no shutdown command if you see that. Let me make this too closely, right? So here as well. Right, I just put the no shutdown. It means the interface is up right now. And after the up this interface, you can see that one thing. My interface went for the blocking state at what point? This is called as a R, right? This is called as a minute. This is called as a second, and this is called as a millisecond. Okay. So now if you see the one part, that's why I'll show you that. So at this point, 43 millisecond, right? 960, 43 second millisecond, 965 millisecond, you have this interface in the blocking state for the VLAN number 1. Because by default, VLAN number 1 is present, right? So we are doing the spanning tree for the VLAN number 1. What happened? This port went for the, at the same point, just for the millisecond, it went for the blocking. It jumped to the listening state now. Add the 15 second in the 43. If you add the 15 second in the 43, how much it will become? 58, right? So you can see that. At this point, 58, same 46 minute, 58 second. What happened? This port go in the learning state. 15 second, listening to learning. And then again, if you see, again, if you add the 50 plus 58 plus 15, it comes to the 13 right now. It's going the porting state right now. The port will be DP because of the switch mode is a root bridge. Same behavior, right? Listening to the learning. And then forwarding. So if you want to see this debug message, you need to use the two commands. One, you have to use the debug spanning tree events. And if you see your second thing, you're going to use the debug spanning tree VLAN state, switch state, sorry. Debug is spanning tree, switch state. Then you can see the debug of this output. Interesting one. It's very helpful to understand the states of the interface, spanning tree interface. Question, guys, I'm done. Anyone has any doubts?
Basically, I mean, there are four, what you call it?
That's called the root, that's the port roles. So port roles are different things, right? Let me write on over here. So two different things we have. We have the port roles, right? So in a port roles, what we have seen that we have seen
Blocking.
designated forwarding, DP port,
Okay.
right? Designated port. Then we have seen that root port. And then we have seen the alternate port. Sorry, blocking port.
But blocking and
Blocking
alternate
is
is the
state.
same thing, isn't
Blocking
it?
is a state. Blocking is a state. Alternate is a port, right? And
Okay.
the states we have in the interface state. One is called disable. Nothing we are gonna do that. Blocking means just for the millisecond it meant for the blocking state. In a blocking state, only we can receive the BPD. But I cannot send and transmit the data. No data send and receive. Even no Mac learning. Then what we have in a listening state. In a listening state, we can exchange the BPD, right? That's not a BPD. Because exchange the BPD, because based on that, we are gonna make a port election. At the same time, we are gonna do the port election. Like a RP, DP, right? Whatever the blocking port will be there, it will jump to the blocking state. But still, I cannot do the no data and Mac learning will be there. Let me put the black one. The third port one is we have learning state. What we are doing in learning state? Exchange the BPD. Are we gonna do the Mac learning? Yes, we are gonna do the Mac learning. But will we know what the data and sending receiving, and the forwarding simple is forwarding. Everything you can do that. Send and receive data. Mac learning. BPD exchange. All you can do. So if you see, so a spanning tree. What you can see that these are my rules. That's my designated. And these are the states forwarding. Understood? So this part is here. This part is here. Questions?
Yes. So that's it really for the spanning tree, right?
We haven't done. That's for the today.
No. Okay. Okay. That's for the today. I see.
That's why we have a, I think so, 5 hours or more class until the CCNP level.
So second please.
For the next 5 hours, we are going to do the spanning tree again. Same next part. For the CCNP level, we have 5 hours more. For the CCL level, we have 8 hours more.
Okay. No problem. That's fine. No worries.
Because I want to show you the layer to load balancing on the spanning tree. So normally people normally don't see that in the production, right? I can show you the live load balancing versus Cisco packet tracer. You cannot do
No,
that. You cannot
I
do
mean, whatever you explained so far, so you explained quite well. I must say that. I mean, it was a little bit tricky, but you clarified it quite well.
Sure.
That's great. Thank you so much.
Thank you, sir. So we'll do the tomorrow the same thing, and not the same thing. Sorry, we'll do the tomorrow the layer to load balancing in the PVST protocol. Then we'll do the TCN BPDO comes in the picture, uplink fast, backward fast. Use things we have done.
No worries.
This weekend, I think so. This complete week, we are going to talk about the spanning tree. Then next week, we have a plan for the DHCP, Ether.
Okay.
From the next week, right? The topics are not so big. So
Yeah,
only
DHCP, DNS are not so big
spanning
there.
tree is a little tricky one. After that, we have a DHCP protocol, Ether channel, we have port security, we have little steps we have. So from the 15th, I'm targeting, right? Let me check my date calendar. Calendar. So from the 15th, not 15th, from the 12th, right? I'm targeting, we are gonna start the routing.
From the middle of the month, basically.
Yeah, middle of the month.
Okay, no problem. Okay, sir. Thank you so much.
Thank you.
Take care.
Thank you so much, sir.
Thank you.